Welcome to my talk called Designing with Malli. And my name is Tommi, and I'm from Metosin, one of the founders. We've been doing Clojure for 7+ years. And so today I'm going to quickly describe Malli and compare it to the other solutions, schema solutions out there in Clojure, and walk through some of the new stuff that is coming. So Malli, what is that? So it took a while to figure out what it actually is, but it's a data validation and specification library for ClojureScript. And it works in the same space as Plumatic Schema and ClojureSpec and many other libraries, but we wanted to build something that is like a unified toolkit, because with if you take, for example, a Plumatic Schema, which is one of my favorites, you need few extra libraries to go with that. And if you take ClojureSpec, you need maybe 7 extra libraries to do what I would like it to do. And we just wanted to test, like, if we put everything into one basket and try to optimize that, what does it look like? So there are lots of stuff in, but it's like basically dependency free. There's 2 dependencies. One is SCI, that's optional, and edamine, that's also optional. But there's schema definition, validation, errors, both machine readable and human errors, then value and schema transformation, value and schema generation, registries, and much more. And there's the URL. And that's the logo drawn by my daughter. She said it was done in 30 seconds. Don't use that, but I think it's lovely. And Malli means a model in Finnish. But if we start with Clojure data, this is like a normal Clojure data definition. It's an address, it's a map with actually a nested map. We have an ID, which is a string, then we have some tags. And when I Googled for garage chicken, there was one. There was somewhere in Bali, there was one like food place in Densapar, and it has some longitude and latitude. But this is how we model data in Clojure. We don't use classes, we use maps and sets and vectors. But if you want to describe this, how would this look like in the libraries, the common libraries that are available? First, with a Plumatic Schema. I think this is the closest representation to the data. If we look at the original address, this is the data value, and this is the schema for that. So it basically shares the same structure. We just, instead of the value, we give this either a class or the schema record type, which describes what it should be. And tags, for example, is a set of keywords. And this is like really elegant and beautiful. And since we started using Clojure and Plumatic Schema was announced, we have been using that ever since, still using that in many projects. Another approach for the same problem is ClojureSpec, and it takes totally different way to do this. So in ClojureSpec, there's this global registry and these keywords which describe basically the map keys, and they have some kind of type. So we are registering into this global registry all the leaf types. There's an ID string, there's tags, which is a collection of, these are all macros, but we just once define all the parts in the schema, and after that we can compose them. For example, there's this address, which is keys, which has unqualified these entries. So looks really different, but it has a good side that once you have done this, and if you are reusing, for example, zip in somewhere in your code, you just say that from this namespace, this chip, and it always means the same thing. In the Plumatic version, all the there could be zip in 2 places, and they might be of the same type, but you have to both introduce separately. But this is Plumatic Schema, ClojureSpec, and then let's go to Malli. So we had this brainstorm something like 1.5 years ago. So what would be a good way to model schemas? And we had these ideas that with regent or whatever you are doing with ClojureScript, if you're using the like hiccup style markup, it looks about like this. And that's like really elegant way of describing data structures, because it's like S expression. You have in S expression you have a list, and the first thing is the like meaning for that. It is the like function what you are calling, and in this hiccup syntax, the first thing is the like schema type, and then it has optional properties, and it has the like children. And the address defined in Malli, we have a map, and its children are entries where the first element is the key, and then there's a type. So there's ID string, tags, which is a set of keyword, and address, which is a submap, street, city, chip, long lat. And we wanted, in Plumatic Schema, the maps are closed by default. In spec, they are open by default, and we wanted to have that. So it seems to be good way to model things. You can like add stuff and it doesn't break. So maps are open by default. Keys are required by default. That's another like opinion we wanted to take. And one extra benefit of having this kind of way to present that is that the keys are in order. It might not matter if you're just like having values, but if you want to like generate, for example, a UI out of that, it's good to have them in order. And this is what the Malli like gives you out of the box. And one really nice thing about having this vector syntax for defining schemas is that you can have the optional properties anywhere in the schema. It's not like hidden metadata somewhere over there, but you can see them. You can, in here, I added some properties to the top level map. It has a title and a summary. And then there's one key, one entry which has this optional true property, which means that the key is optional. And the submap, I added closed true, which means that it's a closed map. So if you add extra keys into the value, it won't be valid anymore. And there's one extra. So there's for the zip, there is default of 33800. And out of these, the optional and closed, they are read by the map schema. The default is just like any data. It doesn't do anything. It's just like documentation, basically. Same goes for title and summary. And this is good because you can add basically whatever domain data you have or you need into the schemas, and you can define the meaning for them in your application. For example, the default, there's this one default transformer which can use that, but in validation, it means nothing. So some applications on top of the like syntax. So validation and human readable errors. For that, we took basically the format from ClojureSpec, the explain. I think that's really, really good. It's not exactly the same, but it has the same kind of elements. So whenever there's error, you get this machine readable like list of errors where you can see in what is the path to the value where the error was, what is the like path in the schema where the value was, all these different type, like was it a missing key or invalid value. And then there's another namespace, malli.error. It has spell checking, so it checks for misspelled keys, and it has these human readable errors. I think this has been really important because you cannot basically vomit out those machine readable errors to humans. They are really long and like hard to read, but there's this small utility which reads those and emits like something which is English, or actually you can localize that easily. But in spec, there's a phrase which is a library doing about the same, but when it was added into the like library itself as a separate namespace, you don't have to use it, but if you use that, it's integrated into the core, so it's really simple to use. Two-way value transformations, that's something that spec doesn't want to cover that. There are at least 3 tools doing that. There's spec tools, there's spec cores, and I think it's coax. I don't know how to pronounce or how would spell, but the 3 libraries at least. And in a Prismatic Schema, it's a one-way transformation, but But in separate Malli transform namespace, you can have these two-way transformations. And then important thing, schema transformations. In Clojure, you can modify or transform your data easily, but we wanted to have the same for schemas. So there's workers, visitors, lots of utilities. You can transform to JSON schema to dot whatnot, and then generating values and schemas. Parsing is coming, it's not out there yet.
Tommy?
Yep.
Two questions. What is two-way value transformation? And how does spell checking works if the map is open?
So two-way value transformation, I have a slide about that later. I can show it. So it's basically like decoding and encoding, which can be symmetric. So what was the other question?
How does spell checking works? If the map is open, so how do you know if it's an error or it's intent?
There's some, yeah, it shows in here. So like it doesn't. So if it's open, you don't know whether it was an extra key or like a spelling error. But there's a utility, you can take any kind of schema and you can say that recursively close it. So you can take like a schema, then recursively close that, explain the value against that, then do the spell checking against that, and then humanize it. So you don't have to modify it. Everything is a pure function, so you are not like mutating anything. But here, because the like child map was closed, we can do spell checking for that. So there is an invalid address. By just looking at it, it's not like totally clear what is wrong with that, but we can first explain that, take that result with the spell checker, then humanize it. What we see that ID should be a string. So that was string in the schema, address, chip is missing, and streets should be spelled street. So that's the three errors we found. Without the spell checking, it would say that there's like street is an extra key and street is missing, but the spell checker knows that they are like close enough and makes them one error. But if you have an open map, you cannot do that, but you can close them programmatically. Good questions. Generating values, this is basically leaning on Clojure, test check. And it's really light wrapper on top of that. But any kind of schema you have, you can just generate value. You can set the size and seed and sample values. Basically, same thing that is already in Prismatic Schema and spec. Have been for a long time, but it's easy to generate values. And you can override those with properties. So you can add these gen/elements, which allows you to like say that when you are generating, this is the like set of values which is used. You can have gen min, gen max, gen, and gen f map to override those per schema. The registry. In ClojureScript, there's the one mutable registry. There are some libraries which are adding extra registry for coercion and stuff. And like we want to take approach that registry is the first class citizen of the whole thing. And it's used for looking up the schema. So whenever you give this like schema AST, the vector syntax into this schema function, it finds the like schemas by type and then passes the properties and children to that like instance which knows how to construct the schemas out of them. So registry is used for lookup, and it's passed as an explicit option, and by default it's immutable. So there are about 100 types in the Malli core. There are these like map and or tuple multi set. And then there's a set of like predefined functions which like can be used like a normal Clojure function, but actually they are like schema mapped into real schema types. But once we did the immutable registry, there was like questions. So could we have this like mutable registry? That would be nice, because if you are coming from spec, it would be nice to have the same kind. You can register wherever, and after that it's in the registry. So there's support for that. There's dynamic registry. There's lazy, which is nice. So you can have this like special lookup. So if you are asking for a schema which doesn't exist, you can run this special code. And there's one nice example of that. There's CloudFormation schema provider, which like you just use these AVS names, and if it's not loaded, it loads them from internet. Then there are local registries, and you can compose them easily. And at the moment, the default is immutable, but there's one special JVM option or Clojure compiler option to swap the default registry. So if you want to have exactly the same kind of mutable global registry as in spec, just like saying into JVM, I know what I'm doing, you can have that. And that's one of the like big things for Malli 1.0.0. So it's under a lot of discussion. Should the default be mutable or is the immutable good? So let's see. If you have opinions, happy to hear them. But this is a local registry. So any schema can have this property called registry. And under that, you can have this like map thing where you have like from the type to the definition. And here we have defined this like, so schema is just like no wrapper. You can do whatever. So this schema returns an order. An order is looked up from the registry, and it's like a let basically. So you have the global registry, but this is like merged into that. So order is found in the registry, and it's a map with stuff, and it has lines, which is an order line, and it goes recursively. There's like country has a neighbor, which is a country. And this is good because like there's nothing which you can't serialize. So you can take the schema and put it to the database and read it back from there. And like, so you can like bundle these like big schema systems as normal data. And like, what does this look like? There's one special namespace called Malli dot, and it has this graphics dot printer. So it takes any kind of schema and emits this graphics notation or dot notation, and you can like visualize that with graphics. There's also plant UML demo I have seen, or the output for the same thing. But basically transforming this into this, it's 69 lines of code. And once the like plant UML tool comes, I'll refactor the common code. So it's maybe 20 lines of code to run this, because it's just a recursive walk over the schemas and emitting this dot stuff. One big difference about related to the like ClojureSpec. So ClojureSpec, the big idea is this decomplex maps, keys, and values. So normally you would say that I have a key which is an ID and it's today an integer. But in ClojureSpec they are bundled. So you say that this special ID is always an integer. And after that you can just say that I'm referring into this ID key and it's always an integer. So you get this reusability. That's a nice feature. And this is the like ClojureSpec implementation. We saw this earlier already, but you define these like global keys, and then you can reuse this. These keys is a key set of these things. So in Malli, you can also do that. So this is exactly the same example. You have a schema which has a local registry which has these like keys and their definitions. And when you have a map, you can the map entry syntax either takes this vector, which is a tuple of key, optional properties, and value, or if it's just like plain value, then it's a registry lookup. So you get that for like free. But this is exactly the same as in the spec. And you can do these like silly things because it's like a let basically. So there's a top level registry and there's an address entry in the registry, which is a map, which also has a like registry. So you can like scope these keys if you want. This is also like totally okay to do. Then the real world. So how can you use Malli today and what's the like relevant features? So first, coercion. And coercion is the two-way transformation basically. So we have these non-closure data structures and we have the closure Eden data structures, and we need to move the data from one realm into another. So we are reading JSON and we would like to have the Eden in. And in JSON, you don't have sets. So if you have defined a schema where something is a set, you have to do this transformation from lists or vectors into sets in the coercion process. But we can do any kind of transformation. So in Malli, it's like two-way, and you can like run whatever like function you would like to do for any kind of schema elements and based on type and properties. But I think it's best to go through an example. So this was our address. It was a map with stuff. And now we take the Malli transform namespace and use this decode function. So we decode against the address this kind of value, and we can see that it does, and we are using JSON transformer to do this. So JSON transformer, this is basically from Plumatic Schema. So everything that can be represented in like JSON has a transformer. So for example, here our schema said that like tags is a set of keywords, but in JSON you only have these arrays. So if you run the decode, you get this, tags as a set of keywords. So this was the like thing which was done in here. But we wanted to make the transformations really good. So it's based on interceptors, and actually Pauli just rewrote that because it was slow, and now it's fast. It's fast, I didn't measure, but it's much better now and much cleaner. But you can make this transformation chain and like apply many transformation in single sweep. So here we take again the address, and we take some data that is coming from outside. There are extra keys, and then the tags are in wrong format. And we have this chain that first we strip out all the extra keys, then we apply defaults, and then we do the JSON transformer. And what happens is that the zip is missing, but it had a default value here. So the default value transformer looks the default property from schemas, and if the value doesn't exist and there's a default, it applies that. And strip just does select keys on these things. So that should be the correct result.
I have a question here. If you show the zip on the previous picture, on the previous slide, not on the schema one, so it should be maybe one more. Yeah, it says there is an integer, but then the default is a string. But after the coercion on 2 slides down, is still represented as a string.
Ah, that was bug in the presentation, but that works totally correct in my opinion. So the thing is that like you can present integers in JSON. So there isn't a string to integer coercion. And now that like the chain is that we first apply the default, it puts the string in there. Then it runs the JSON transformer, and the JSON transformer sees that there is a string, but it should be an integer, so that's an error. So if you go to the next step and after the decoded, you ask validate, it will say that this is wrong. If you would change this to string transformer, it would do the string to integer conversion. Because like in strings, it's like for query parameters, whatever, which only can have strings. So you have to, if you want an integer, you have to do the string to int. But in JSON, like it's an error, user error. User should be sending the like. But this is the wrong. This should be the like integer. Then it would like apply a real value. But the like decode process is totally separated from validation. So this just does the best effort transformation, tries to make it like correct, and then you have to validate it afterwards. So 2 sweeps. And this is a sample about like what you can do with the like transformation chain. So there's like separate decode and encode keys that you can attach to this. We have properties into the schema. So here we have decode string, which is a function which does lower keys something, and then the encode does it into the other way around. And when you decode this legacy string, you give something that is coming from the legacy. It runs the decode function in here. And the other way around, when you are like coming back from your Clojure world and putting it back to HAL, then you do encoding. So these are symmetric. And here we have the, what is that called, quote. So you don't need to have that. But if we do that, this is like not evaluated. And if you have SCI in your system, it will do the evaluation for you. So you can persist this also to the database. And when you get it back, it's all just like symbols, and the evaluator, the SCI, like evals that. And it works in ClojureScript too. Another like silly example about the transformation. So you can have these like, because they are interceptors, you can affect the values while going in and while going out. And that has relevance in some cases, for example, map keys. But here, when we are entering the value, we add olipa into the beginning, and when we are leaving, avaruus into the end. And when we decode that, we get this olipa kerran avaruus. And you can combine these. So there are cases when these are needed, all the like features, but usually you don't have to worry about those. The default type transformations are all good. This was one of the main reasons for building Malli, because we did spec tools, and spec tools try to add coercion into like ClojureSpec. But because it's done from outside, it's a monstrous hack. It works, but like it's not very clean code, and like for some reason that is not in the scope of ClojureSpec. There are many libraries trying to do that, but they're all best effort, because to try to run the transformation, for example, regex specs, you have to like reverse engineer the whole regex spec, like realm. That's a huge amount of work. So it just can't ever work perfectly. They're all best effort, but in Malli it's built in, so it works all the time. Inferring values. So small sample. So it's opposite of generating values. You like give a sample of values and get a schema back. And first time I used that was for this like big MongoDB database. There was 5 years of data, and like there were some problems, and I thought, oh, this is a nice proof of concept. So if this works, so what all the values in the collection, I just like invert a schema and then like accumulated the schema union, and all the documents had a timestamp. So actually there was a temporal schema index built out of this. So this is like quite nice. So you can, and the union was good because it showed all the typos that have been added there, because there was no schema validation those days in MongoDB. So there were like extra keys which were misspelled, and they would never work again in the current production system. But that was a nice finding. And here's an example. So how it works. So there's a Malli provider inspired by the spec provider and F# type providers. You just like give a sequence of values to it, and it takes a best guess out of the schema. And this was also a good example, because there were two examples. One had lat lon and another one lon lat. And because we don't know which one is true, or actually we want to return a schema which is valid for both. So there are two keys, both are optional. And at the moment, it doesn't handle the tuple. So it just sees that there was vector of two values, and I'm not sure whether it was a tuple. And the whole provider is 69 lines of code also. So lots of like leaning on the core feature. So it should be made much better, but it works, and it's quite nice.
How the functions are returned, as a symbol or as a function?
Oh, okay, that was a good question. So there's the default registry has these about 40 like keyword schemas. For example, map. So map is mapped into this implementation, how map is implemented. But then there's also like some core functions from Clojure core, which are mapped as function values. And because of that, you can use normal like functions. So here, what is returned is a symbol. But if we go back, where is our schema? When we have defined this address, here it is actually the function. So if you like look at print out this address like data, this says that object something, because that's the the one and only string implementation. But when the registry like builds them, there's like double mapping. There's this string function is mapped into this string implementation, and like a string symbol is mapped to the same implementation. So you can have both of them. And whenever you say that what is the form of this address, it always returns the like quoted version. So they look exactly like this. But here, basically what it returned is this is like a instance of the schema, but its print representation is the type, which is the symbol string. So these look like symbols, but they are actually schema protocol verified instances. But you can take any schema and say, give me the form of the schema, and it returns exactly the original thing without
So you can send a schema over the wire easily?
Yes, you can do that. I can show that. There's this playground where you can play with the schemas, and like it stores them on query parameters.
And then it's a symbol. It's the symbol.
Then it's a symbol. Yeah, then it's a symbol, and you can write the schema into an Eden file, and it's a symbol, and it maps to the same instance that it would map if it was a function. But the double mapping is the key. And serializing schemas, this was like one great things that we wanted to do. So in those project things we have built, we did this like purely data-driven schemas, which were like custom for those projects. But we wanted to make Malli fully serializable, and thanks to like SCI and EDA-MEM, it works. So mostly everything can be presented as normal data without macros, and you can put it to the database, read it back, and also like read it back, and it works on ClojureScript too. The SCI runtime on ClojureScript is something like maybe 200 kilos. So like if you can afford that, you can have all the features. It's an optional, the SCI, and it works on Graal with VM2. I cannot change now my screen, but in the end, I will show the Malli IO. That's the playground for the things.
And does it work with non-anonymous custom functions?
No, it doesn't. So if you have something that is, it doesn't like get the source code if you have like this non-registered function, but you can have an anonymous function if you just quote it. There's an FN wrapper which allows you to put any kind of anonymous function there. Okay. And here's like one example about the like writing the. It doesn't have much to do. It's also already like plain data. No, there's an integer, and so adult has a local registry. It has an age which is an integer which is more than 18, and then it has this one key age. And there's this Malli Eden. You can write it as a string, and then you can read it as string, and then it's just like a normal reified schema. It works. So one of the last things, programming with schemas. This is something that we wanted to perfect. In Prismatic Schema, we built the schema tools library, which has all these like helpers already, and we have been using them a lot. And like there are no such thing in ClojureSpec, but we wanted to have that Malli would have this. So you can take any schema and transform it basically like it was data. There's like this pre-walk and post-walk. You can walk recursively over them and use this visitor pattern to like accept the nodes and do something with them. Then there's update properties, get, assoc, update, all the core functions in this Malli util namespace, which takes these schema instances and like works on them. And that's backed by this length schema and schema protocols. And this is a good example when you like optimize the whole. So we added this later and realized that like if this would be a separate library and we couldn't modify the core, this would be really hard to do. But now that like the core is just one namespace and Malli util is another namespace, we can like push all the requirements from the Malli util to the Malli core and add these few extra protocols and make things here easy. So this is like benefit of like building all the features into one library instead of having this like set of 8 libraries which have all the same features for parsing and stuff. Example, here was the address, and for the address we do this transformation. So first we select the keys from the top level ID and address, then we update the address by dissociation latlon, and then we associate the top level properties just data. And what we get back is a new schema instance, which has those modifications. Another nice utility because we can program with the schemas easily is the sub-schemas. It's maybe 5 lines of code, but this is really useful for generating UIs out of the Malli schema. So it basically flattens the whole nested tree of schemas. So you get this vector of elements where there's path. Path is the path in the schema where the element is, and in is the value path. So if you have a value, you can say get in with that value, and you can point directly into the nested data structure. And then there's a schema, and all these lists. There's somewhere I can see my pointer, but in the middle of the page there's this tags Malli core/in, which means that tags is a collection, and there might be many of those. So it's an index basically. So tags 1, 0, 1, 2, 3. And so on. So it's a hint for the UI generation to generate a list component out of that. But that's few lines of code, and we added that into the Malli utility because it was so useful. Few more things. How's the time? I guess we have time. Dev tooling. So this is the new stuff. This was not the original goal of Malli. We wanted to make something that works for runtime, because that's the basic place where we are working. But it was a nice exercise to see that can we add things which are basically implemented in ClojureSpec and are really done well there. So just how would they look like in Malli? So first, function schemas with higher order functions, and added way to describe them in Malli. That's just one schema implementation. And then this tool that you can annotate any Clojure var with Malli schemas from the outside. Multi-rarities. So one thing that seems to be missing from ClojureSpec is the multi-arity with custom returns. But it was easy to add because it is needed also. So multiple arities, and each can have their own value. It currently doesn't support var args because the sequence schemas are at the moment work in progress. After that, it will support also those. And good thing is that it integrates the CLJ condo, so you get these static analysis out of that. And there's a separate namespace for this Plumatic Schema style inline schemas. That's not committed into the master branch, but that works. And then there's this separate ghost wheel port of Malli, which is called Aave. And where here is the screenshot of the syntax. So we have this Malli schema and Malli core, and first there's this Plumatic style inline schema. So we can have this. We have this defen, which is the there are 2 macros in the whole library. This is one, and it's optional. But you can say that this fun takes a tuple of integer int and positive int, and it returns integer. Actually, sorry, it returns a tuple of int and positive int, and it takes 1 integer. And another example, we annotate existing Clojure functions with this arrow symbol. And then if we just hook it up to CLJ condo, this is the old screenshot, but we call mc/emit. It writes this CLJ condo config file, and after that, it automatically picks up those errors if it can. So, but in the end result, there's Malli to CLJ condo transformation which does this, and that's kind of fun. But there are a few schemas in a few slides in here. CLJS browser is something we wanted to also target, and it took some time to figure out how to do that because I hadn't done it ever. But with help of all the kind people from Slack, we managed to do a pretty good job there. So there's it's quite small. I think it's 1.2 kilobytes, the absolute minimum I could make out of Malli core. So if you take these strings and maps and vectors and numbers and just use validation, the dead code elimination removes everything else. All the you don't have to use these Malli error namespace. You don't have to use transformers, and the Malli core itself like strips into bare minimum. So if you want to do that, so that's really nice for that. GraalVM, that's a target. So at the moment, the minimum is 14 megabytes. There's the sample application in Malli repo, which takes this like a schema and a value and pretty prints, is it valid or not? And it runs in few milliseconds, I would guess, and it's 40 megabytes. If you use SCI, I think it was a bit more. I can't recall how much. Coming to the end. So Malli is now in alpha. It was pre-alpha for almost a year. We didn't want to actually it was more than a year. We didn't want to hurry that up because whenever you were adding like new namespaces, new feature sets, you had to modify the core, and we were breaking the core a lot. It's not fun to use the library that breaks a lot. So we wanted to make it good, and now it's alpha. It's pretty stable, but there are a few big things which were not ready for the alpha. So, and they will be small or bigger breaking changes. So this will be coming hopefully soon. And the things which are in the radar. So first, support for sequence schemas. That's basically a rewrite from like Christoph Grant's Sexpers. I don't know how to pronounce, but that's really fast way to do regex, and that's Pauli is doing that. That looks really nice. And after that, schema parsing, that's coming. First class schema inferer. At the moment, the schema inferring is a bit slow because it tries brute force all the register schemas, and there are a lot of predicates that if you give like a string to a certain function, it will throw this number error exception, and because it throws a lot of exceptions, that's pretty slow. But lifting those like inferring into schema, so each schema knows how to infer or accept the value, like makes it really fast and first class. And then the interesting thing, so at the moment, so Malli, you can describe data with Malli, but you should be able to describe Malli schemas with Malli also. There was the same idea with spec, with this spec of specs things some years ago, but I don't know what happened to that. But that's really nice. So there would be two functions in the like Malli like protocols. One would be like give me the Malli definition for the properties for this schema element, and give me Malli schema for the children. And it also requires the sequence schemas. Expand create pretty printer, that's like basically done in the first stage, but that's lost in some branch. That's work in progress. Proper documentation, that's important because at the moment there's big README which has all the stuff, but like it's really hard to like read or find anything from there. That's bad. It would be fun to, when you look something like JavaScript libraries which do validation, they have really like nice documentation sites. We should have that too. And then the last, revisit some design decisions, including the global registry. So should it be like easy to use when you just take Malli? You just like register a few things and they are available. Now, if you want to have your custom schemas, you have to either have this own like immutable map and pass it to all functions for validate, for explain, for many places, or you have to have the JVM hook that I know what I'm doing, and then you can like swap the default register. But maybe it should be the default, I don't know. But wrapping up, designing with Malli. So where was the designing part? So this was a Malli presentation, sorry about the title. But Malli is a clean slate fusion of best parts of existing libraries. It has been really fun to like write that and use that. So Plumatic Schema, the big inspiration, and ClojureScript, like, which has some brilliant parts, and we have just like taken those and giving credit to those, definitely. But like trying to see what would it look like, the like schema library of our dreams. It's in alpha under active development. There was the closures together for 3 months, which enabled me to write a lot of extra stuff and get the alpha out. But now there's a list of ideas that's really long and not that much extra time. So if you are interested in developing Malli, like come to the Slack channel Malli and like please help with the issues. There are a lot of issues with help welcome and lots of like features which are just increments on top of the existing thing. And reitit Malli is the one library that if you want to use it in real world, you can take reitit and there's an existing module. I can try to change now to my browser if I can, because how do I do that? I want to share my share browser. Can you see?
Yes.
Yeah. So this is the playground, and here you can see how the different features work. This is like a bit small, but for example, there's any schema which you can write the schema and a value, and it says whether it was valid, are there errors, it gives sample values, it gives you JSON transformed JSON schema, Swagger, dot representation, and then some invert schemas and from samples, and then some other things. But let's go to some more relevant. So here's a good example that XY map. It's a map with X, which is an int, and Y, which is an int. And we have composed so that we are using this anonymous function which takes X and Y from the top level map and says that X must be greater than Y. And it has these properties, and the Malli error has this error namespace, and you can put error message which says that which was the error, and you can see it here that X should be greater than Y. And if we fix that, it's fixed. And the whole schema, it's serialized in query parameter, so you could also put it to the database or share this. There's user, which has regexps, and wanted to show that actually in regexp, in ClojureScript, there's no generator for that. So we are using this genf map, which constantly returns this one value in ClojureScript, but in Clojure, there's a generator for that. There's an address which does something. There's multi. So multi is like a multi-spec, but it's closed. You have this multi, you say how you dispatch, what is the dispatch function, and then you have the dispatch branches. So here it's type, which is the dispatching thing, and then there's sized and human, and they point to these different maps. Here's some recursion. You can have recursion using the registry. So there's console, which is maybe a tuple of int and reference to console. So ref is the recursive reference. And then you just say that this seems to be valid, and it generates sample values. Order, this was the thing, was in the slides also. So this is local big register and values. And the last one is pet. And this is the using multi. So we have a registry which is pet and cat and dog, and there are these some declarative utils for doing schema manipulation. So we can merge. There's a pet which is the base schema, and then cat is merge of pet and something else. Dog is merge of pet and something else. And then what we are returning is a multi where we dispatch based on type, and we just point to the reference instance. Cat and a dog are the valid branches. Either one of these. And when we see that sample values, there's cats and dogs, and they have different skills. And here you can see, for example, the generated JSON schema. So there's from Malli to JSON schema. There's not from JSON schema to Malli. There's open PR for that, but it hasn't progressed in few months, so I think it's stalled. But in JSON schema, that would be either a cat or a dog, and the definitions are in local registry. So this is valid JSON schema. And that's good if you do API documentation. And one thing is the Malli reitit. The example. So if you want to test it with web library, there's this example ring Malli Swagger. Just the normal application, which is for schema and for spec 2. So this is the Malli version of that. So there's one file, and there's some beta. Got it. And here we can see that this is the routing tree, and there we have said that there's some multi-path parameters, then some body parameters as Malli schema, and like that. One thing I didn't mention is the performance. So we are really keen on making stuff as fast as possible. And at the moment, the transformation engine, it's 1 to 3 orders of magnitude faster than spec tools. So if you are doing busy websites and using some kind of coercion solution in Clojure, you should definitely try benchmarking with Malli. So there's this compiler which pre-computes as much as possible, and if there's nothing to do, it will return nothing to do. But that was my talk. So happy to take any questions or chat with you people.
I have a couple of questions. One is I'm a fairly new, well, I'm an intermittent Clojure user, as in sadly it's not my day job. So often having to return to code that I have struggled to write and then can't read the next time I come back. So is it possible to effectively insert a Malli command inside a function that could actually, given the data flowing through the function, could actually generate a schema for that, what was actually coming in? Does that make sense? To help you understand, oh, this function is actually taking this in and it's generating that. Because that's one of my problems, is you come back to a function and it's got loads of, maps and reduces and all the rest of it. And you think, well, what on earth is that actually doing at each step?
Well, that was an interesting question. So definitely that is possible, because at the moment there is no such thing as instrument, which is in ClojureSpec, where you can, based on the existing spec definitions, you can put this validation onto functions at development time. But I think this would be the opposite, basically. Mm-hmm. So you could say that start collecting and wrap all the functions in this one utility, which records what is going in and what is coming out, and after that you can use the inferring to see what is the schema coming in or out, and after running all the tests you would get this this was the union of all the stuff which came in and out. Mm-hmm. Okay, so that would be really easy to do, but doesn't exist. But that was a good idea. If you would like to see that, please write an issue to the Malli repo. So happy to implement that. That shouldn't be many lines of code.
The other one is I see a lot so I've played around where I actually want to generate a Clojure client based on a Swagger rather than the server, and often it's the other way around, that basically you get stuff that will generate you the server but not actually the client. And is there a way of doing that with your stuff, that actually you could generate something that would actually drive somebody else's Swagger schema? So for example, in my work, I mean, I'm not a Java programmer. I pretty well can only write Java. I hate Python. Sorry, I can only write Clojure. So I end up, I've got basically Swagger APIs coming out of my ears, but I'd like to be able to drive those from a Clojure client. And therefore, quite often you just want to read the Swagger generated client. And so is that something that you guys have done on the basis that you can already translate from Malli to Swagger, etc.?
So at the moment, it's one-way trip. So if you have a Malli schema, you can generate JSON schema out of that, but there is not the opposite. So at the moment, if you read Swagger, you get these JSON schemas, and there should be this JSON schema to Malli converter. And after that, you would have everything running in Malli. So you would be you could validate those inputs and generate stuff. But at the moment, it doesn't exist. There's one tool for Clojure called Metosin, which is for Plumatic Schema, the same thing. So it reads the JSON schema and creates these Plumatic Schema things and gives you some kind of client. I will try to find it.
Thank you.
Okay, guys, thank you very much. So what I'm gonna do is stop the recording so that we can have just a chat, an informal chat with Tommi. So thank you very much for Tommi. That was a really, really great talk. And if you're watching this from YouTube, please remember to like the video and subscribe to the channel. We post a new Clojure related video pretty much every week. And if you want to talk to one of these sessions, get in touch with me with the London Clojurians meetup. I will post the link down in the description as well.